Everybody ready to go here? You have a good weekend? Yeah?
Good morning went by too quickly, though.
Pardon me?
The mornings went by too quickly.
Yeah. All right, well, I think it's just about time. Does anybody have any questions over anything we've done? Anything you want me to go over? Homework was okay? So I was thinking about starting with a quiz today. I was going to just let you all decide. It's either going to be today or next class. If we do next class, then what we do today will be on that quiz. So if you feel like you're ready, to have a quiz over what we did last time, you can vote for now, and if not, we'll vote for later. So how many of you want to do it right now?
Would that just be 4.7?
It would just be like the power rule, the antiderivatives of things to powers, pretty much. Okay.
Would we be able to use the reference sheet?
You can use your notes. Yes, you can use the formula sheets. Sorry, not notes. Your formula sheets you can use on anything in this class. All right, that looks pretty unanimous. Let's just do a quick one-question quiz. Separate sheet of paper. Put your name on the top. Put your name. Put today's date, which is 9/11. It's been 22 years.
And can we go over 25?
Let me see what it is first. If it's where? Yeah, since that's not going to be on the quiz, we'll maybe address that after. Okay. All right, let's get going. So one question, right? Number one. Just show me you know how to apply the power rule, and then a couple other things. So that means find the antiderivative, right? Let's keep it simple. It's Monday. Simple and fast, all right? This should not take you too long, all right? We voted, everyone wanted to take a quiz today, so one question, real quick. Yeah? You'll know what I'm asking here?
Do we have a timer for this one?
Fast, go. Yeah. This should not take more than 5 minutes. So this is a cube root, 4 times the cube root. When you're done, just bring it up to me, please. Just set it up here. That way I'll have an idea of how many of you are finished. I'm going to put some notes up here. It has nothing to do with the quiz, so just ignore me over here. Okay, one more minute. Thank you. Thank you. All right, anybody else? Okay. Okay. You ready?
You said find an antiderivative.
Yes. Uh-huh. All right, is that everybody? Yes? All right, so today what we're going to do is we're going to talk more about what we ended class with last time, which was U substitution. And so what I want to begin with here is just an idea. Now, if you had me for Cal 1, I'm going to take a slightly different approach on this and see how it works, all right? So the idea here is that if we're trying to find the antiderivative of something, and when we look at this thing, we see in the integral, right, in the integrand, I should say, we see that we have composition, all right? We have, if we just look at that right there, that means you have f with g plugged inside. So you have some function g that is being plugged into some other function f. That's composition. If we see composition and the function that's being plugged into f, we also see its derivative within the integrand, then we're going to make a substitution. Now, I'll show you an example here in a moment, but I need to finish this. So what we're going to do is we're going to replace this g of x with u, and then if we differentiate this implicitly with respect to x, derivative of the left side with respect to x, derivative of the right side with respect to x, we get this. And then if we multiply both sides by dx, we get this. And what this allows us to do is rewrite this integral, and I was kind of running out of room here, so I'm going to do it here. So now what we do is we rewrite this, and when we rewrite the integral, this new integral becomes integral of f of, and now we've replaced the g of x with u, right? So we're going to replace this here with u, and then we're replacing the entire g prime of x dx with du, right? This piece right here gets replaced with du. So this part becomes du right here, right? Those are the replacements, here and here. Those two things are getting replaced. And then this just means, okay, go find capital F of u, right? The antiderivative of little f. Go find its antiderivative and then add a constant. Do y'all remember to put plus c? Did y'all remember to put plus c? Okay. So this is the idea of substitution written out in like a formula format. Let's actually do an example. All right, so let's do something. I'm going to start with one that it's very easy to see. Well, relatively speaking, it's easy to see this. So I'm going to go with, let's go with x cubed plus x plus 1, all raised to the 7th power. And then next to it times 3x squared plus 1 dx. All right, we want to find the antiderivative of that. It looks terrible, right? When you first look at that, it looks absolutely horrible. So we're going to try and see that we have composition here. We have a function inside of some other function, and then also the derivative of that function is sitting here somewhere as well. And do y'all see it? Do y'all see the g of x? What is it? Yep, this right here. This right here is the g of x, and its derivative is right there as well, right? Well, actually, yeah, we'll just put that like that, right? That's its derivative right there. So do y'all see we have it? We have g of x that's inside some other function, and then we have the derivative of that g right here, and then we have dx. So if g is sitting, if g is inside of some function, what function is it inside of? Like, what's the composition? What's f here? It's the power of 7, right? It's this power function. So this g is inside the power function, 7th power, right? So we're going to just make the substitution now, right? So let's make our substitution. I'm going to say let u be equal to my g of x, which was x cubed plus x plus 1. And then I'm going to take the derivative of that, right? du dx, derivative with respect to x. That should equal the derivative of this, which is 3x squared plus 1, right? That's this step right here. And now, this step, we're always going to solve for du. So we're going to multiply both sides by dx every single time we do these problems. And so later on, I'll stop actually writing this step. I'll just go straight to this. du equals, we've got this 3x squared plus 1. I'll put in parentheses dx like that. That's just multiplying both sides by dx. Feel good? So now what we do is we rewrite, right? We're going to rewrite the actual integral. So when I rewrite this, this new integral becomes the integral, okay, I had something to the 7th power. The thing that's being raised to the 7th power was my g of x, right, which I'm calling u, right? So that's just going to be u to the 7th power. And then all of this stuff out here, all of that is what? du, right? So that's just u du. Or sorry, u to the 7th du. I don't necessarily need the parentheses anymore, so I'm just going to write it this way. And see, now you're just trying to, this is like back to what the quiz was. It's power rule. You're trying to find the antiderivative of u to the 7th, treating u as your variable. So the answer to this should be 1/8 u to the 8th, right, plus some constant. And we're almost done. We have to switch u back to x, right? We made a substitution. We need to switch everything back to x. So this will be 1/8. What was u right here? X cubed plus x plus 1, all to the 8th power plus c. This should be our result. So the idea of substitution is that when we're looking at the integrand, we need to see something, and this is where in my notes, my lecture notes for this class, what I do is I call this thing something, all right? That's actually what I name it, something. We never know what it's going to be, it's something, right? And then what we also need to see here is the derivative, right? The derivative of the something that we're seeing. Do you all agree that that is something, right? And that is its derivative. That is the something, and that is its derivative, okay? Now, in my notes, which I'm going to show up here on the board, and I don't know, this was in here today, so I'm thinking they might hook this up, and so I might have screens on both sides. I didn't ask for it, but I won't complain. So in my lecture notes, what I say here for this section is, you know, I give you kind of some steps here. And look at the first step, right? The first step is look at the integrand, right? Look at it, okay? And then you're going to try and find something and its derivative. So I see something here, right? And I see its derivative there, right? That's step 2. Step 3 is important, all right? Look at what it says. The derivative, right? That means this piece right here. The derivative should appear in the numerator and not be trapped. What that means is when you're looking for that derivative piece, if it's down in the denominator, it doesn't work. If it's trapped under a root or inside a parentheses being raised to a power, if it's inside of a trig function or something like that, it's no go. This thing has to be free, okay? And the reason it needs to be free from everything is because it's going to turn, what does this turn into for us? What does all that crap turn into for us? du. And du needs to be the thing on the back of the integral. It can't be like down on the bottom or inside a sign. Does that make sense to you? It needs to be free from that. That's the first thing. That derivative of the something should be in the numerator, not trapped. And then look at step 4, or number 4. The derivative might be off by a constant. And that means that it could be off by some multiple. So that's okay. Here, we're not off by a multiple, are we? I mean, it's exactly, the derivative of that is exactly this, right? But it would be okay if it was off by a constant. So that's what I'm going to show you next. I'm going to show you I'm going to just tweak this problem. I'm going to make this derivative be off by a constant, and we're going to see we can still do the problem, all right? Now, as soon as you get to step 5, you say, okay, let u be that something, right? And then from there, you do the rest, right? Take the derivative and go for it. All right, so let me tweak the problem a little bit. So what I'm going to do here is I'm going to change this. I'm going to make this, how about we make it 9x squared plus 3. And that marker's done. All right. So you're sitting here and you're searching, right? You're saying, okay, do I see something and its derivative, right? Do I see something and its derivative? Do I see something and its derivative? The derivative has to be in the numerator, can't be trapped, and it can be off by a constant. So I kind of just have to pick something and go for it. Like, I'm going to go with this, right? I'm going to say, let's just try this. Let's see if that was my u. Okay, if I try that, the derivative of this is what? 3x squared plus 1, right? And then it turns into 3x squared plus 1 dx. And do you see that these don't match, right? These don't match. But how could I make them match? There's a couple of ways you could do it. You could factor 3 out of this, right? Up here you could factor 3 out. Or you could take this and multiply both sides by 3. Which one do you want to do? It's totally your choice. There's no right or wrong way here. You just need to make them look the same. So how many of y'all want me to just factor 3 out of this? Factor 3? Anybody just want me to multiply both sides by 3? Okay, so it's up to you. Most of you wanted me to factor 3 out, so what I'm going to do here is I'm going to just come up here. If I pull a 3 out of this, I'm going to pull it out in front and then out of the integral. And I talked about that last class, that when it comes to integrals, constants can go out front because the idea that constants come for the ride both when you're differentiating and when you're doing antiderivatives. So the 3 is going to come out, the x cubed plus x plus 1 to the 7th. And now, since the 3 came out here, we have 3x squared plus 1 dx. And they match now, right? This matches with this. And so the only difference, I'm not going to show all the work, the only difference between this problem and the one before is, if we ignore the 3 and bring it down, then this should be the same answer we just got, right? And we just got what, 1/8 something, right? 1/8 x cubed plus x plus 1 to the 8th plus c. So the only difference is that we'd have a 3 out here instead. Now, some students ask me, hey, does this 3 need to be distributed through to the c? What do you think? Do I need to put 3c here? I don't need to put 3c. Because technically I should distribute it, but what's 3 times a constant? Still a constant, so it doesn't matter. It doesn't have any impact. So this would just be, if I were going to write a final answer, I would do like 3/8 x cubed plus 1 plus x cubed plus x plus 1 to the 8th plus c, and box it up, we're done. All right? Okay, so what I did before class is I went to a different textbook. In my office, I have like tons of calculus textbooks from different authors. And I printed off an exercise set of U substitution problems. I have a handout for you. I'm going to do a bunch of even problems here, and then I'm going to give you those. These are just optional for you to practice, all right? Just in addition to what you're being asked to do for homework. If you want more practice, I've got problems for you. But I don't want to hand it out yet. I want to just go through some examples. So the first example that I'm going to do here is, I should probably wait and do this one after, but I'm going to do it because it's the first problem that they have here, the first even problem. All right, they say, all right, 8x plus 2 to the 1/3 power dx. And the reason I don't like this as like a first problem out of this is because This one it's not as obvious as the one we just did, right? The one we just did, like you could see the something, you could see its derivative, it was very clear. This is a little bit tricky. So do you all see the something? Do you see the function that's being plugged into, do you see the function that's being plugged into some other function? Any guesses as to what it might be? 8x plus 2, right? Okay, 8x plus 2, if you let u be 8x plus 2, let's just try it, then what would the derivative of that be? What's the derivative of 8x plus 2? Just 8, right? And then I told you I'm always going to just get the du by itself. So 8 dx, right? Do you see this? Do you see that? Because I said you need to see something and you need to see its derivative here. Do you see that derivative there? Kind of. Not really, right?
You can bring the 8 up to the front, but make it 1/8.
Yeah, so what you have to see here is there is a 1 here, right? There is a 1. And isn't 1 off by a constant with this? It's off by 8, like a factor of 8. This is why I don't like this as the first example, because the something, its derivative is not obvious because it's the 1, but being off by a constant. I hope that makes sense to you, right? So what I like to do, okay, this is just the technique I like to use, is I pick my u, I take its derivative, and I get this. And then what I do is I look back up here and I say, can I rewrite this so that it has just u's in it, right? No more x's, just u's. So what I'm going to say is, all right, this right here, 8x plus 2, that right there, I'm going to replace that with u, right? So that part's going to be replaced with u. And then I need to try and see if I can replace somehow the 1 dx with something. And so what I do is I come here and I say, well, shit, I have 8 dx. That's a 1 dx, right? So I'm going to make this a 1 dx by doing what on both sides? Dividing by 8. All right? I'm going to divide both sides by 8. Or if you like, you can say I'm going to take 1/8, multiply both sides by 1/8. And there I get 1 dx. I don't need to write the 1, but I'm just trying to be clear that I'm trying to make it match this piece. So I'm playing this like matching game, where what I'm doing is I'm making a substitution, and then I'm seeing what I get when I take the derivative, then I'm trying to fit that into this, and rewrite this so that it has nothing but u's. So can I rewrite it now? Yeah? Okay, it'll become the integral. Okay, this is the blue part. The blue part became u, so that's u to the 1/3 power. Times, now the 1 dx became 1/8 du. And what can I do with that 1/8? Pull it out, right? Pull that 1/8 out. So 1/8 comes out. Integral, now I have u to the 1/3 du. And that is just a basic power rule, right? That's what today's quiz was about. So I'm going to use the power rule. 1/8 stays. The power rule says the integral sign goes away, right? I take that power, I add or subtract 1. Add 1, right? I have to add 1. What's 1 plus this? 4/3. But out front I have to put 1 over 4/3, don't I? Which is 3/4. So 3/4 u to the 4/3. And then don't forget your plus c. So I'm skipping some steps here. Like I'm not showing this work because that was last week, right? And I told you all this, we want to be able to be proficient by the next time we come back, and that be something we're comfortable with. It might take you a few more steps, that's fine, but I'm not going to show those steps. Okay, can we simplify this? 3/32, right? U, okay, what was u? I'm ready to switch back. 8x plus 2, all of that raised to the 4/3 power plus c. Box it up, we're done. So again, this is an example where the something, right? Here's the something. And the derivative of it is in the numerator. It's not, it's not trapped, it's by itself, but it's off by a constant. It was off by a factor of 8. And we fixed it, right? We fixed it right here. Questions there? Okay, you sure? I want to keep this up. let's see. So they follow this one up with another one that's similar, all right? But we're going to do it. We're going to crank these out. We're going to see if we can do all these. 7 minus x to the 49th power dx. So right now, let's take a step back for a second. Right now, the only thing you know how to do here is if you have x to powers, right, separated by addition and subtraction, you can do them individually using the power rule, right? We learned that last week in the beginning. The other technique that we're learning here now is this U substitution, right? That's our second sort of approach to things. That's all we have though, right? Those are the only two things we have. What's going to make things difficult for you later is when we have all 5 things. And you look at a problem, you're not quite sure which one to go with, right? So right now, it's still relatively simple because we know it's this, right? So we just need to figure out what the substitution is. So what is the substitution? Y'all see it? 7 minus x. Okay, so as I write this down, if I let u be 7 minus x, what's the derivative of this? Negative 1. Do you see a negative 1 up here somewhere? We have a 1 again, don't we? Okay, so 1 is off by a constant from negative 1, right? So that's going to work. So I'm going to just, I'm going to go straight to this now. So instead of writing du over dx equals negative 1 and then multiplying both sides by dx, I'm going to do it all in one step. And now I get to play my little matching game. So the 7 minus x right here, right, that's going to be replaced with u. That's this piece right here is going to be replaced. I just need to be able to replace now the 1 dx, right? This 1 dx needs to be replaced with something. Here I have negative 1 dx, so what should I do to get 1 dx? Divide by negative 1 or multiply both sides by negative 1, however you want to look at it. This is going to become negative 1 du equals dx, right? This is my dx right there. It's going to be replaced with this. And now I can rewrite the problem, right? Look, these are the beginning problems. These problems are going to be pretty straightforward. Okay, new integral becomes, all right, this right here was u, so u to the 49th power. And then times the 1 dx gets replaced, that was a 1 right there. The 1 dx gets replaced with negative 1 du. I'm going to pull the negative 1 out of the integral, and actually I'm just going to put a negative in front of the integral because that's the same as a negative 1. And then I'm going to have u to the 49th du. And now just power rule, right? Add 1 to that, you get 50. So we'll have negative 1 over 50, right? We always have to scale by that power. U to the 50th power plus c. And then equals negative 1 over 50. Last step, replace u with 7 minus x plus c. There we go. And what did I tell you all last time when we started talking about antiderivatives? What's the good news when it comes to antiderivatives? You can always check your answer, right? You can always check your answer by taking the derivative of this. If I take derivative of this, I should get that right there. Well, without the dx, just I should get that, right? I'm not going to check it. I think that that one's a little too straightforward. All right, we ready to move on? Do something a little bit different? Okay, how about this one? How about we're going to use a different variable, t instead of x. Down here we're going to do the cube root of t squared plus 9 dt. I don't think I've talked about this in this class. If I have, I apologize. When I write t's, I curl them. My Cal 1 class knows this, right? I curl my t's at the bottom. That's something when I was in Cal 2, I didn't do that. I would do my t's like that, and I would do my pluses like that, and they looked too much the same. So I started curling my t's. Just if you're going to do more math, that's just something you might want to think about doing. Also with z's, my z's, I strike my z's so I don't confuse them with my 2's. You know, there's little things like that in math. What's that?
Also, I do with my zeros too, I put a slash through it so I don't confuse it with like a
So you don't